Hi everyone. For this video, we're going to have an introduction to calculus and we'll start with limits. So when we say limit of a function, it is the value it approaches as the value of x approaches a certain value. So meaning to say, if we have limit of f of x as x approaches c, that will approach a value L. So let's have an example to illustrate this. Let's say we have limit of 1 plus 3x as x approaches 2. So this means in the number line is that as we approach x 2, okay, so as we approach x 2, what would be the f of x? Okay, so we can have like values that approaches 2 from the left and values of x that approaches 2 from the right. Okay, let's do that. Let's make a table. So let's start with from the left. Okay, so what are the numbers that approaches 2 from the left? So that would be 1, okay, 1.5, 1.7, 1.9, we have 1.99, okay, and let's substitute these values in 1 plus 3x. So f of 1 plus, so f of 1 is equal to 1 plus 3x. So that will be 1 plus 3 times 1. So that's 4. Okay. And we continue substituting that with the rest of our x. So for 1.5, 1 plus 3 times 1.5 is equal to 5.5. Okay, so do that with 1.7 and we'll get 6.1. For 1.9 we'll get 6.7. For 1.99 we'll get 6.97. Okay, now let's do values of x from the right as it approaches 2. So that would be, we can start with 3 and then 2.5, then maybe 2.1, then 2.03, then maybe 2.009. all right, and then let's substitute these values of x to our function. So f of 3 is equal to 1 plus 3 times 3. So that's 10. So this is 10. For f of 2.5, we have 1 plus 3 times 2.5 is equal to 8.5. And we continue doing that for x is equal to 2.1, 2.03, 2.009. Okay, so for 2.1, we'll get 7.3. 2.03 will be 7.09. 2.009 will be 7.027. Okay, what about we try 2.0001? We get 7.0003. So what can we say about these values? So from the observation that we can see here, okay, as the values of x get closer to 2, the values of f of x gets closer and closer to 7. Okay, so let's write this way. So for the limit of 1 plus 3x as x approaches 2 from the left side, so this is a left hand limit, okay, it approaches 7, and the limit of 1 plus 3x as x approaches 2 from the right, okay, so this is the right hand limit, is also 7. So as you can see, our one-sided limits, the left hand limit and the right side limits, are equal. So if they are equal, the limits exist, so we can therefore say that the limit of 1 plus 3x as x approaches 2 is equal to 7. Okay, let's have another example. Let's have the limit of x plus 2 as x approaches 4. So once again, with our number line, okay, 0, say that's 4. So we can approach 4 from the left or from the right. Okay, so let's have values of x from the left side. So that would be 3. Then we can have 3.5, 3.7, 3.9, 3.99. Okay. All right, so let's do this. So f of 3 is equal to x plus 2. So 3 plus 2 is 5. Okay, then substitute f of 3.5. So x plus 2, 3.5 plus 2 is equal to 5.5. And we keep doing this for our x, 3.7. So that will be 5.7. For 3.9, we have 5.9. 3.99 is 5.99. So that's from the left as it approaches 4. Now let's do values of x as x approaches 4 from the right. So we can have 5 and then 4.7 and then 4.5, 4.1, 4.01. All right, let's use our calculator, or we can do this mentally. So f of 5 is equal to x plus 2. So we have 5 plus 2 is 7. F of 4.7. So we have x plus 2. 4.7 plus 2 is 6.7. For f of 4.5, so x plus 2, 4.5 plus 2 is 6.5, and then we have 6.1, and then 6.01 for x equals to 4.01. So from the observation, what do we notice? As x approaches 4, our f of x approaches 6. So let's write that. The limit of x plus 2 as x approaches 4 from the left side is 6. And the limit of x plus 2 as x approaches 4 from the right side is also 6. So the left hand and right hand limit is once again equal. Therefore, the limit exists. So the limit of x plus 2 as x approaches 4 is equal to 6. And when you graph this, when you graph these values, okay, and you will also see that it's approaching y equal to 6. Our next example is limit of f of x as x approaches 2 if f of x is x squared minus 1 when x is less than 2 and x minus 4 when x is greater than or equal to 2. So we have two subfunctions, or in other words, we have a piecewise function. So in this case, once again, we're going to use the number line. So as x approaches 2, okay, so we have approaching from the left and approaching from the right. Okay, so let's start the one from the left. So we have 1, 1.5, 1.7, 1.9. We can have 1.99. Okay, so in this case, our values of x is less than 2. So we're going to use this function, x squared minus 1. So if x is equal to 1, so 1 times 1 is 1. 1 squared is 1 minus 1, so that's 0. If it's 1.5, so 1.5 squared minus 1, okay, and we have 1.25. If it's 1.7, so 1.7 squared minus 1, we have 1.89, and we'll do that also with 1.9 and 1.99 squared, so minus 1. So for 1.9, the answer is 2.61. For 1.99, our f of x value would be 2.96. Now let's do the right hand limit. So from the right, so we have 3, and then 2.5, then 2.3, 2.1, 2.01. Okay, so our x values is greater than 2. So this time we're going to use this function x minus 4. Okay, so 3 minus 4 is negative 1. 2.5 minus 4 is negative 1.5. 2.3 minus 4 is negative 1.7. 2.1 minus 4 is negative 1.9. 2.01 minus 4 is negative 1.99. Okay, so we have the limit, the left-hand side limit, x squared minus 1 as x approaches 2 from the negative side. It's approaching 3. And for our right-hand limit, so we use the function x minus 4. So 2 plus, and as we can see, it's approaching negative 2. So we can say that from these values, our left-hand limit and right-hand limit are not equal. So if they are not equal, therefore, the limit of the function does not exist. Okay, and even if we graph this, so let's graph. So our x squared minus 1, so 1 is 0, 1.5 is 1.25. Okay, so this should be a parabola. 1.9 is 2.96 over here. All right, so this is the sketch of our x squared minus 1. And then our x minus 4, so we have 3 and negative 1, 2.5 and negative 1.5. 2.3 and negative 1.7. So it's here. So as we can see, our parabola and the line, the piecewise functions, they don't connect, so doesn't exist. So from the table, from our left-hand, right-hand limits, and from the graph, it shows that the limit of the function does not exist. That's all for today, and our next video would be about the different theorems of limits. Thank you.